Okay, so in this unit, we're going to look at something that's called a direct variation. And a direct variation is a linear relationship in which one variable is always a fixed multiple of the other variable. So basically that means that I can take the independent variable and multiply or divide it by some number to get the dependent variable, and that works every time. So for example, the y value will always be 3 times the x value, would be one example of that. The important parts to notice about a direct variation are that the graph is always, let's see, in a graph of a direct variation, the slope of the line is a fixed multiple and the y-intercept is always 0. So what that means is that the graph is always a straight line. That's what it means by the slope of the line is the fixed multiple. So in the example above, the y value is always 3 times the x value. That means the slope of that line would be 3. If it was the y value is always 10 times the x value, the slope would be 10. Okay? So the graph is a straight line and the slope is the same as that multiple. And what it means by the y-intercept is always 0, it always starts at this point right here, which is it starts at a point which is 0, 0. It starts right at that corner. Okay? So if it's a direct variation, the graph is a straight line where the slope would be the fixed multiple between the independent and dependent variables, and the y-intercept is always 0, which means the graph starts at 0, 0. So let's look at an example. The dispatcher of a school bus company is monitoring the local weather forecast. So he's looking at snowfall. At 9 a.m., there is no snow on the ground, but it has started snowing. It is predicted that 2 centimeters of snow will fall each hour through the night and into the next morning. So, sorry, that was 9 p.m. There's no snow. So at 9 p.m. there's no snow, and then every hour after that there'll be 2 centimeters. So at 10 p.m. there'll be 2 centimeters. At 11 p.m. there'll be 4 centimeters, and so on and so forth. So what is the initial value? So the initial value is basically our starting point, or our y-intercept, which is what we talked about in the direct variation equation. So what is the initial value? That is the amount of snow on the ground at 9 p.m. So the initial value would be 0 centimeters, because at 9 p.m. there was no snow on the ground. What is the expected rate of change? So the rate of change is how, in this case, would be how has the snow changed in comparison to the change in time. So the rate of change, which is the same as the slope, would be 2 centimeters of snow will fall per 1 hour of time passing. So 2 centimeters per hour would be the rate of change, which will also be the slope of the line, because rate of change has the same value as a slope. So the neat thing about that is now we know that because the slope is the same as that multiple between the dependent and independent variables, we know that there's going to be a multiple of 2 in there. So C says create a table of values for 0 to 10 hours of snowfall. How does your table show the initial value and rate of change? So let's have a look at a table. So just put that right in there. So there is, at 0 hours, there's 0 centimeter of snow. At 1 hour past, there's 2 centimeters of snow. 2 hour past, there's 4, and so on and so forth. So the initial value is right here. At 0 hours past, the depth of the snow is 0. And that lends itself to that 0, 0, 0, 0 start point that we talked about. So that first value is 0, 0. So that lends itself to being a direct variation. the rate of change, you can see, is what, it's not only what the depth of snow is increasing by each time, so the rate of change is 2, and the depth of snow is increasing by 2 each time, but also, let's look. If I look at 1 hour times 2, I get the depth of snow. 2 hours times 2 gives me 4, the depth of snow. 3 hours times 2, I get the depth of snow. So, just like in our example, we said the y value is always 3 times the x value. In this case, the y value is always 2 times the x value, which means that the rate of change, or the slope, will be 2. All right, so the next one is, how does it show the relationship as a direct variation? So for D, we'll say it, the y value is always 2 times the x value, and also it has that 0, 0 point, which means the y-intercept is 0. And those are the big important parts of a direct variation. The y-intercept is 0. Okay. E, predict what the graph of the table of values will look like. Well, that's super easy because we know that a direct variation, the graph is always a straight line. We know that multiple value is going to be the slope. And we know it has to start at that 0, 0 point. So the graph, if I'm to sketch it, would have to start right here at the 0, 0 point, and it would be an increasing line with a slope of 2, which means for every 1 that it goes over, it would go up 2. If it goes over 2, it would go up to 4, and so on and so forth. So it would have that slope of 2. So at what time will there be 12 centimeters of snow on the ground? So we can just look at the table, and it's right there. So so in 6 hours, right? So we would do 9 p.m. plus 6 hours, and that would be 3 a.m. Okay. And G, the decision to cancel buses must be made by 6 a.m. How much snow would be on the ground at 6 a.m.? So 6 a.m. would be 9 hours after the snow started to fall, which would be right here. And it would be 18 centimeters of snow on the ground.